Hi everyone, this is John from Studio Digital Resin, and welcome to another demonstration of the GxCircle command. Today I'm just going to carry on from the demonstration I gave a few days ago, where I didn't have enough time to show all the features of the GxCircle. So I'm just going to open up a drawing which I did again today, pretty similar to the last demonstration, where we have a set of circles which were created by center point and radius point. Here we have a point which is created by bays on a curve, being this spline, and so we end up with a point which has got multiple subpoints. So I've chosen this one as the center point, and we have another point which lies on the second spline, and this point is also created by bays on a curve, so it subdivides the curve. And obviously when you select this point as the radius point of our circle, then we get multiple circles created. So that's all pretty self-explanatory. If you're wondering how I did this, just look at the previous GxCircle demonstration. So just to show you what happens if you try to modify the radius point. In this case, all points that are based on a curve, you can't modify them directly. You have to actually modify the object on which they lie. So in this case, it's the spline. And to modify a spline, you need to just select one of its control points. So as I move this control point, the spline changes, and if the spline changes, all the points which lie on the spline need to change as well, and obviously all the objects which rely on the points, they also change. So here we can see that all the circles will change in real time as well. And when it's done, then you can see the results of your change. Also again, just to show you that this works in 3 dimensions as well, whereas the standard AutoCAD parametrics don't allow you to do modifications in 3 dimensions. So you can change your design in real time just to see what the results of your changes are going to be. This is obviously quite helpful in many cases where you try to do this sort of geometric setup with vanilla AutoCAD. I've actually never tried it, and I don't even know if it is possible. But anyway, so here we have all the circles controlled by their radius point, and therefore they're all facing towards the radius point. So their direction is determined by their creation method. Now, there may be cases where you've got a design where you want all the objects that lie on points to face in a different direction. Say for instance you're trying to model a set of shields or satellite dishes, should I say, and you want to see how changing their direction alters your overall design. Doing this again in vanilla AutoCAD would be very, very difficult, especially if you have a lot of them. I'll show in a future demonstration how, say, creating a set of windows and altering their direction on hundreds of them will be done quite easily using this mechanism. So in order to do this, I have to bring up the control panel, which is GxCP, and then I select the circle in question. It doesn't matter which one you choose, because these circles all belong to the overall controlling GxCircle object. These are all sub-objects of the GxCircle. So it doesn't matter which one you select, they will all come up here under this circle name. Now there is a property here called the normal point. So this property here allows you to override the direction which all these circles face. So when the circles are first created, their directions are all calculated for you. But now I'm going to make it so that all of these circles face this point. And all you have to do is you type in its name. So you hover over the circle, and we see it's called GxPoint09. So I come in here and I type GxPoint09, hit enter, and now all the circles face this point. Let me just show you what that looks like in 3D. If I go back to the top view and modify the position of this point, you will notice how they will all face the point. And if I make this modification along the z-axis, for instance, they will all follow it. So now we're below the z-axis of 0. Let's go to side view. This is a bit difficult to do in non-3D. I'll just change our orientation ever so slightly. Too much. And there you go. Now, if you had a design where lots of entities or lots of your geometric elements need to point in a specific direction, this option here is quite useful, quite handy, and you can. And what's nice about it is you change it in real time, so that you can actually get a visual grasp of what's happening in your design without needing to first move your point somewhere, click finish, and then see the result of what you've done. So this feature allows, this sort of feature in the property editor allows you to specify the name of another entity instead of, say, a value. So a radius point, basically all points need to be a name, because you can't type in a number for a point. It has to be the name of an actual point. Another feature which I will try to demonstrate is how you can change the size of a circle based on the length of another element. So if I delete these just to unclutter the drawing. So now I will create a circle with an entered radius along these points. I'll do 200, for instance. No default offsets. Okay, so now these circles all have a fixed radius. And let me just regenerate the background drawing. So these circles all have a fixed radius, and their behavior is exactly the same as the previous one. And you modify the object on which they rely, they all change, and you can see how this affects the spline, how the spline affects the points, and how the points affect the circles. So these guys can also have a normal point, and the normal point I'll set again to GxPoint09. And now they will all face the normal point. And if you modify the normal point, they will all face the normal point. Now, to show you the modification of the radius. So the radius is a value which I've typed in here. So this is a value that you can change. If I change it to 300, you'll see how they all get larger. Now I'm going to actually change the size or the radius of these circles by specifying the property of something else. And to do that, I'm going to use a line. So a line requires a start and an end point. So I have 2 points already. I'll choose by start and end point. I'll pick point 9 as the start point, point 10 as the end point. So we have a line here. The line is called GxLine 01, and it has a length, as you can see, of 235 units. So if I click on line, it has a property called length. So you can use that property of GxLine 01 as the radius for these circles. So I have to go back into the circle properties, and if I type in GxLine 01 dot length, hit enter. Now if I come here and modify the line, you will see how all the related objects, in other words the circles, how all of their sizes will change as well. I come back in here and I take away the normal point, hit enter. They go back to their default, which is the normal of the center point. And if I modify the line, again, the same thing will happen. Their size will change. So what this lets you do is it allows you to control the size of other geometry based on something else in your design. This is quite useful if you have other elements which control the size of other elements, or determine at least the length of other elements, which is quite common in a lot of architectural designs, for instance. And if you wanted to change that part of your design just to see how it might look afterwards, you can imagine how time consuming this will be if you needed to do this on many elements, whereas AGX will allow you to do this quite quickly and in real time. Let me just demonstrate, for instance, how this performs. If I come back here into the point, so the point was created by Bayes on curve. If I set this to 50, hit enter, we get 50 points, or actually 49 because I've not included the start and the end. These are also options which you can change. So now we have a whole series of circles, and if I come in here to change, you will notice how this changes as well. Changes all of them. Clearly, the more elements you have, the slower this gets, because that is just the nature of the update mechanism. But again, if you were trying to change 50 odd circles one by one, this would probably take you the best part of a day. And if you needed to modify the object on which the circles lie, or the points lie, again, you can just imagine how long that would take to have to change their position, orient them again on the line or the curve, and then change their rotation based on how the X and Y and Z axis of each point reside. And this is clearly the benefit of a parametric system in that it just does all of this for you. So now if I go back here and I just modify these points back to the original 10, oops, a slight problem to fix there still, but I'll get onto that soon enough. And if I go ahead and change the, actually no, I need to delete this circle entity. Let me create circle by center point and radius point again. Make these just a little bit smaller. For the time being, or AGX at least has no ability to create three-dimensional solids or surfaces. That feature will come once all of these sorts of geometric qualities have been tested fully. But in essence, you would be able to spread, say, a surface over these circles by just specifying one, and then you would be able to have a loft, for instance, which would then loft your surface over these circles, and then when you modify the splines, then your surface will obviously change. But you can still do this with AutoCAD's surface associativity. But even for the time being, just to show you how, if you do have a surface which relies on closed loops, in other words these circles, now naturally AutoCAD's surface associativity makes sure that if any of the objects which built this spline, the surface change, then the surface will change along with them. So in this case we have 10 circles. Obviously if you needed to modify all 10 of those circles, what AGX allows you to do, of course, is to change the circles in the way that you need, in whichever way that you need, and then once they change, so does the surface. Let's take a quick look at this in X-ray mode. So here I have quickly altered the circles. I will alter this one here just to show you. And then of course the associated surface changes. So this is built in, but at least when this feature comes into AGX, so that you don't have to manually choose each circle, should you have quite a lot of them, AGX will create the surface for you, and it will obviously use AutoCAD's built-in surface associativity to maintain the associativity with the circles. So clearly, if you do have any three-dimensional geometry, three-dimensional surfaces which rely on, say, lofts, this will definitely cut the time in which it'll take you should you decide to change any of those elements which control the surface in itself. Okay, so thanks very much for watching, and stay tuned for the next video.